exactly this microprocessor and microcontroller and why we need to study and what are the contents of the course. Today, what we do is like we have seen the entire syllabus, the course, how it is framed and all. So now let us go ahead further. Before like going to in the last class, what we have seen is microprocessor or microcontroller can be treated as a programmable device. So when it is programmable device, how microcomputer structure is, how the computer structure is built around microprocessor is what we have seen by seeing different IBM PC architectures. So now what we do is, so the conclusion from the last class is this. So any system, programmable system, is built around microprocessor. So if you want to know the capability of microprocessor, then we need to know about the architecture of the processors. So now let us see the architecture of a generalized processor. If you can understand this architecture, you can understand either microprocessor, microcontroller, or the DSP processor is. So now let us see the architecture of 8086, and before going to do that, let us see the generalized architecture of a processor is, right? So now let us see. Now, so architecture is what we are talking about, and yeah. So now in the last class we have seen any microprocessor based system will look like this. You have a microprocessor, you have memory, right, and you have input and you have an output as. So this is how what we have seen a generalized von Neumann architecture is, right? So now in this class what we are going to see is, so this is the processor we are talking about. Any programmable system right, any programmable system follows this architecture. Then to know the capabilities of the processor, what exactly the processor does. So if you want to see the capability, right, so then what we need to do is, you need to see the architecture of the processor is. So the first topic of the course is the architecture of the processors, right? It is an architecture is what we are going to see in this particular classes. So now not only 8086, the processor which is introduced in this course, you have to see either a microprocessor or a microcontroller or the DSP processor. A generalized architecture is what need to be understood. So then now let us go ahead with to understand the architecture of the processor, what we need. Now, so this is how a microprocessor based system will look like. Then we need to understand the architecture of the processor, right? So now let us see how it performs the task is, now processor, your system is based on the processor, then all the tasks performed by the processor can be divided into three categories. I repeat, to understand the capabilities of the processor, we have to know the architecture. Then, if the architecture, if you want to see, then let us try to understand how is each terminology is. So then, this is how the system look like. Then the microprocessor based systems will perform three tasks. One is, initially any microprocessor will initiate certain operations. So the first, that means all processors will do three tasks, or the tasks done by the microprocessor can be categorized into three. One is microprocessor initiated operations. Microprocessor initiated operations. Then the second one is internal operations. In the first, processor will initiate certain operations. In the second, some operations are internal within the microprocessor. So we divide them into internal operations. And the third task is external initiated operations. External initiated operations. So I repeat, all the tasks performed by a microprocessor can be categorized into three. One is microprocessor based operations, or we can say microprocessor initiated operations, and the second task is internal operations, and the third task is external initiated operations. Okay, external initiated operations is right. So now let us go ahead with, right. So first we will discuss this, next we will discuss this, next we will discuss this, and we'll try to come towards the architecture of the processors. So I'll try to show you the architecture of 8086 and 8085 processors. So in the last class we have seen the evaluation. So listen carefully and then we'll go ahead. The first task, that means any system, if it is microprocessor based system or programmable system, its architecture is like this. When the architecture is like this, the system is designed around the processor. When the system is designed around the processor, you have to know the architecture or the tasks performed by the processor. So all the tasks performed by the processor is categorized into microprocessor initiated operations, internal operations, and externally initiated operations. Now let us see one by one, right? So now the first one is what we are discussing, that is nothing but any system, that means now the processor will initiate certain tasks. So microprocessor initiated operations is what we will try to see first. So this is how the system what we have taught. This is what the microprocessor, this is what your memory, and this is what your IO, input output devices, which are connected to the system. So in the beginning, the processor will initiate certain operations. That means what? When you switch on the system, when you switch on your mobile phone, it comes like it is Nokia or Redmi, some kind of thing. How that is happening? So the processor will initiate certain operations in the beginning. So now let us try to see what are those. Now, under microprocessor initiated operation, the processor will do certain tasks. Then what the processor will do, now let us see. The processor will do memory read operation. So the processor will do memory read operation. That means when you switch on a system, you need certain booting instructions. What do you mean by booting instruction? To start up a system, you need few instructions like Nokia, Redmi. That is how it is displayed on the screen. That is called booting instructions. So those booting instructions are stored in the memory or can be an IO. So processor has to do these tasks. What are the tasks? Right. So the processor, so it will do a memory read operation, or the processor will do memory write operation, or the processor will do IO read, input output read, and the processor can do IO write. That means what are the tasks done by the processor can be categorized into this only. So in memory read, what it does, it reads the data from the memory. Memory write means what it does, it will do memory writing, data writing into the memory, or IO reading or IO writing. So now these are called initiated operations. That means the processor will do all the tasks done by the processor, means either it will read a memory, or it will read a IO, or it will write into memory, or it will write into IO. So now to do these particular tasks, first thing is to read a memory, it has to identify the memory. Memory reading is good, but it has to identify the memory or IO. So to read the memory or IO, first thing it has to do is it has to identify the memory or IO. Now, that means the processor has to identify a memory or IO. So how it does? So this identifying the memory or IO is done by using a set of communication lines called address bus. So I repeat, a processor will do either memory read or memory write, IO read or IO write. So this memory reading or IO reading done by using set of communication lines called address bus. So bus means what? It carries passenger from one place to the another place. So here in electrical domain, what do you mean by bus? A bus is a set of communication lines which carries the address from the processor from where it has to fetch a particular instruction. So that kind of thing. So then that is done by using a set of communication lines called address bus. So this address, that means every processor or every controller or every DSP processor should have an address bus. That means what? When you switch on a system, it need to read the booting instructions. From where it has to read booting instructions or some instructions, means you need to identify a particular memory. So that identifying the memory or IO can be done by using a set of communication lines called address bus. So that means every processor should have address bus. So it carries address from microprocessor to memory, and that's why they are unidirectional. Unidirectional. That means the processor tells from where you need to read the memory, from where you need to read the memory. So then the address is provided by the processor, and address is carried from processor to memory. So address is transferred in one direction only. That is why they are called unidirectional. And in architecture, this is shown with this symbol. Means what? It is unidirectional. right? So now let us try to see the significance of address bus. So that means what we said, that means each processor should have address bus with it. Then that particular address bus. So how many address bus? A processor can have 10 address lines. A processor can have 20 address lines. A processor can have 30 address lines. So then the memory which you can connect to a processor, the size of the memory which you can connect to the processor depends upon how many address lines it has. I repeat, the memory which you connect to a microprocessor depends upon how many memory lines you have. So the memory addressing capacity of a processor depends upon the how many of address lines with the processor. Now, each line will carry binary number, either or 0. Then you have, like if you have 10 address lines with a processor, so then 2 power 10, which is 1064, means each line can carry either 1 or 0. So if you have 10 lines, 10 zeros, 10 zeros to 10 ones. So that is the address. So the altogether 2 power 10 is 1064 is the address lines. That means it is if you are a processor and it is your memory first location, second location, third location, so on. 1064, 1064 location is what you can connect. That means a memory, if you have a processor has 10 address lines, then the memory which you can connect with any processor is like 1064, that is 1K. This is what we call 1 kilo. And the memories are fabricated like this. Each location can store 8 bit. Each location can store 8 bit. And like that 8 bit. So there are 1000 means 10 power 10, 2 power 10 locations, and each location can store 8 bits, right? So then it is called 1 kilobyte. What do you mean by this? If any system is designed around the microprocessor and the microprocessor has 10 address lines, then the addresses can range from 10 zeros to 10 ones, that is 2 power 10, which is 1000. It is 1064 or 1024. There 1K, 1000 locations you have. 1000 locations, each location can store 8-bit data. So then, which is equivalent of 1 kilobyte. Right? If a processor has 20 address lines, then you can access 2 power 20, which is 1 MB. 1 MB means what? 1 megabyte means there are 10 power 6 locations. Each location can store 8 bit of data. So then now we are discussing what is the significance of address bus. The significance of address bus is the memory accessing capacity of a processor depends upon the number of address lines you have. So the significance of address lines is the memory which you can connect to a particular processor is this. Now you have your mobile phone. You can connect 8 GB. Extendable is what we say. You cannot connect 1 TB. So that means the memory accessing capacity of the processor means wherever you store your data in the memory, it has to get access. It has to access the data. So then the memory accessing capacity of a processor depends upon the number of address lines it has. Okay, right? So this is what the thing is. The first task the processor will do is identifying the memory. So that identifying the memory is done by using address bus. So if a processor has 10 address lines, then we can say 2 power 10, which is 1K, 2 power 20 is what 1 MB, 2 power 30 is what we can call 1 GB, 1 gigabyte, 2 power 40 is what we can call 1 terabyte. That means based on the number of address lines you have, you can connect memory to your systems. So I think you can see the color. Color is a problem. So now let us modify the color. Okay, so that you can see. So better I can go for one more. Yeah. Control Z. So I can go for the design. Then which number system we are using? The number system which you are using is hexadecimal number system. Yes. So 00H means what? Each zero is of again in terms of binary means 4 binary bits you are using. So now you have to know the counting, right? So counting means now I have to give an address for this, I have to give an address for this, I have to give an address for this. So then if I use one single digit of this hexadecimal number system, which is of 0, 1, 2, 3, then 9, A, B, C, D, E, F. If I use only one digit of hexadecimal number system, then I can give addresses for 16 locations only. But now if I use two digits, then 09, then 0A, 0F, then 10, 11, 12, so on up to 19, 1A, 1B, and so on. So if I use two digits, then I can access the last is FF. So then F into 16 power 0 plus F into 16 power 1. So F is 15. So 15 into 16 power 0 is 1 plus 15 into 16. Right? 15 into 16. So all together you have 255. So if I use two digits, I can 0 is added. So 0 and 255 means 256 locations I can give addresses. Similarly, if I use three digits, then I can, the last number is all zeros to all Fs. All zeros to all Fs. So that means now you can think like F into 16 power 0, F into 16 power 1, F into 16 power 2. So which is around 4K. Right? But here, how much memory I can connect it to 8085 processor? Like 64 kilobyte. So 64 kilobyte means I need to use 4 digits. So my first address is 000H. That means this 0000H. Next address is 0001, 0002, so on up to 9A and all. So the last address is FFFF. So this is what you know when you are dealing with the processor and the memory, this is what you have to know. So 8085, the conclusion is 8085 processor has 16 address lines, means you can connect 64 kilobytes of memory. And for giving 64 kilobytes of memory, the addresses you have to give all zeros to all Fs. But in our syllabus, the processor which is there is 8086. Then 8086 has 20 address lines. How many address lines it has? 20 address lines. Then these 20 address lines means you can access 2 power 20. That means 1 megabyte. 1 megabyte means there are 10 power 6 locations are there. There are how many locations? One location, second location, third location, fourth location, go on up to you have 10 power 6 locations are there. So then how many digits need to be used to give addresses of all these locations? Then the answer is the first address is 4 digits when you used 64 kilobytes is what maximum you can go. Then you need to use 5 digits. Then 5 digits to the first number is this. The next address which you can give is this. The next address which you can give is this. Similarly, 000AF, then 10, right, 00FF, then after FF, 00, here you have 100 like that. You have F, 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 F. This is the last address of the memory which you are connecting to the 8086 processor is. So this is 00000H and it is F, 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 4 and 5 Fs. So this is your last memories. So I conclude the microprocessor initiated operation and all these things which I am talking now, I'll show you in the architecture. So 8086 processor has how many address lines? 20 address lines. And how much memory you can connect it to the 8086 processor? If you have here, you can connect 1 MB memory. And any byte from any location has to be accessed by the processor. And who will do the task? Your address bus will do the task. So the memory accessing capacity of a processor depends upon the number of address lines it has. And 80386 has how many? Two means there are 32 address lines. So when it is 2 power 32 address lines, 2 power 2 and 2 power 30. So is what we can say 2 power 32. That means 4 gigabyte memory is what you can connect. Now you can understand. Now your cell phone has 8 GB memory. So 8 GB memory or 4 GB or the RAM, internal RAM, if it is of Redmi mobile phone, if you take, if it is of 2 GB, the cost can be 6,000. The moment it is 3 GB, the cost is 9,000. That means the memory, the primary memory has that much significance it is, right? The RAM which we are talking about. So any processor, its memory accessing capacity depends on the number of address lines it has. All right. So this is the first requirement of a processor is. Then we will go ahead with the next thing. So this is what 8086 processor, and we are talking about the address bus is right. So the number of address bus it has what? This 0 to 7, 8 to 15. Total 16 address lines are there. Right? So now let us move on to the next topic. So here we are discussing microprocessor based on how they works. So the requirements of the processor is. So then the next task, so this is what you have to keep in mind. So it's from this you have to understand the architecture. The beauty is that. So here you have the microprocessor, here you have your memory. The memory can be RAM and ROM, right? And here, this is what your IO is, right? So then, once a particular memory or IO is identified, the next one is the data need to be transferred. So the next task, what it does is data transfer. So the data has to be transferred from memory to the processor. So this data transfer, so here what is data? Binary. This is digital device now, ones or zeros. So there you need some set of communication lines which will carry the data from memory to the processor. So this is your processor, this is your memory. Then that is called, so this data transfer can be done by using, so data transfer, the transfer of binary information is done by using a set of communication lines called data bus, right? Data bus. So any processor should have data bus. So now you see this pin diagram. 8086 processor has AD0 to AD7 and A8 to A15, 16 address lines it has, which we discussed. Then from the processor, the data has to be transferred from memory to the processor or processor to the memory. This is done by using a set of communication lines called data bus. So then 8086 has 8 data lines. 8 data lines. This is 8085 microprocessor. And 8086 microprocessor has 16 data lines. 16 data lines means it can carry 16 bits of data at a time from memory to the processor or processor to the memory. Then based on, we can say the data bus is a bidirectional line. Bidirectional bus. Bus means what? Group here. Bus means it carries the information. It is set of communication lines. So it is bidirectional bus. So data bus is bidirectional, address bus is unidirectional. So the data bus is this. So by this is means data has to be transferred from memory to the processor, or once the processor does a particular task, it will write back into memory. So data transfers from memory to the processor or processor to memory. That's why it is called bidirectional data buses. Right? So now that is the use of this data buses. So with 8086, how many data lines are there? 1, 2, 3, 4, 5, 6, 7 and 8 data lines are there. And similarly, with 8085 processor, 8086 processor also I will show, it has 16 data lines. That means it can carry 16 bits of data at a time. So then the next task, what it does is in microprocessor initiated operations. So now it fetched the first instruction. Now it has to fetch the next instruction. So you need, that means either processor is doing a memory operation or processor is doing either IO operation. So you have to know the status. So then here, so you need some status of the signal, so that can be shown with the help of few lines called control lines, or you can call it as control bus. So example is what? Read, you can say M by IO bar is called a control line. Means what? You are doing a memory operation or you are doing a IO operation is indicated by some certain pins, right? So then if you like you are doing a reading operation means, so reading means the data transfer is from memory to processor. So you can know the control or you know the status of the processor is. So that is done through some control lines or control bus is what we can call. The example is M by IO bar pin kind of thing, and then read write bar up kind of thing. So I conclude, like, in internal operations. So in internal operations, right? So the processor will identify the memory. The processor will transfer the data. The processor will transfer the data, right? And the processor will indicate certain controlling, or it will do some like some status kind of thing. So in microprocessor initiated operations, you can put this all task under this. The processor will identify the memory, and once it is identifying the memory, the data has to be transferred to the microprocessor, and then the processor will execute, and then it will take certain decisions. So it will do some internal operations, and that with the help of the microprocessor will do the internal operations with the help of address lines, with the help of data lines, and with the help of control lines. With the help of control lines, or we can say control bus. So every processor should have these things: address lines, data lines, and control lines. So the moment you see 8086 microprocessor, and you have to see all these things, right? Not 86, any microprocessor, if you go through, then you can see all these things, right? So now the second task, so what we said microprocessor will do, all the functions performed by the microprocessor are categorized into three. One is microprocessor initiated operations, and then internal operations. The second operation is internal operations. That means, so here, this is what your microprocessor, this is what your RAM or ROM, your memory, right? And then here you have your IO. So now, once the data is fetched, right, read by the microprocessor, the processor will do on chip certain operations, and those operations are called internal operations. Those operations are called internal operations. What are they? Now let us see. So once the any memory location is identified and data is transferred onto the processor, it will, the first task which we'll do under internal operation is the data need to be stored. So the data need to be stored temporarily. So temporarily. So this, that means the data has to, you have to perform some task on the data. So then the data is on the processor. When it is on the processor, then there should be somebody to hold the data. So the data need to be stored temporarily. So who will store the data temporarily? And for that we use a resistor or resistors. So any processor should have registers to store the data temporarily on the processor is, right? So this is what a resistor. Like our resistor, attendance register, what it has a student's roll number, it has student's name, some kind of thing. So that is a storage. So similarly, what is electronic resistor? Electronic resistor is of the type flip-flop, which can store either 1 or 0. So then set of D flip-flops, it is 8-bit resistor means what? 8 D flip-flops are connected. 8 D flip-flops are connected. If it is 8-bit resistor, 16-bit resistor means what? 16-bit flip-flops means 16 flip-flops are connected, which can store either 1 or 0. So then every processor should have a register. Then once the data is stored on the register, then the processor need to execute the instruction. The processor need to execute the instructions, right? The processor need to execute the instructions. So this execution is done, right? So it is like execution means what? Performing arithmetic, logical operations. So it is performed by whom? ALU, arithmetic logical unit. So any processor should have arithmetic and logical unit in it, which will perform this task. So the task is what? Performing arithmetic and logical operations is. So this is done by using ALU in combination with accumulator. Accumulator. The word I'm introducing now is an accumulator. What is it and all we'll see. Right. So this is accumulators. Right. So now ALU. What is this ALU? Adder, subtractor, multiplier, all kind of these tasks, like performing arithmetic tasks. So ALU is of 8-bit. If you have an 8-bit ALU, means the microprocessor is 8-bit microprocessor. If you have ALU is of size 16-bit, then the processor is of 16-bit microprocessor. Now, if you have an ALU on 32-bit, means the microprocessor is of 32-bit microprocessor. What do you mean by this? If the processor is of having ALU 16-bit, means it can do addition, subtraction, anything 16-bit of data at a time. It's a capability. So a microprocessor is of 8-bit, 16-bit, 32-bit or 64-bit. Depends upon the ALU size, not on everything. Please note, your i3 and i4 processor, how many bit processor? i3, i5 and i7, they are 64-bit processor. The moment we say 64-bit, what do you mean by it? That means it has an ALU of 64-bit in it, right? So this is what the second task the internally the processor will do. Then the next task, so processor has executed an instruction. It performs some arithmetic operation. So then you need testing for conditions. That means what happened? What happens to the result? Then you need to test for the conditions. So this testing for conditions is done by using a specific resistor called flag resistor. Is called flag resistor. What is it and all we'll see. So this flag resistor means it is an 8-bit resistor with an 8086 microprocessor. It has a bit called carry. That means what? When you added 8 bits, right? Then is there any carry or not? Means this flag, this means this flip-flop will become either 1 or 0. It stores the status. Okay. So the status of the execution need to be done. These are all internal only. So then that is done by using a resistor called flag resistor. So that is what the significance of the flag resistor. It is sometimes called status resistor too, which indicates the status. Next, one instruction is fetched. Next instruction need to be fetched. So then the next instruction need to be fetched by the instruction means there should be somebody who can identify the memory of the next location. So then the next task is what? Sequencing of the instruction. That means somebody should be there who can put then the sequencing. That means sequence the operations. So this sequencing, that means what? You need somebody, a pointer, which will point out the next memory location from where you will fetch your instructions. So this is done by using a resistor called, you have program counter. So what do you mean by this program counter? This program counter will identify the next memory location which you are going to, right, which you are going to. So sequencing the operation is done by using program counter. So 8086 has 16-bit program counter means what? Can identify any 64 kilobytes of location, right? So this is what the program counter is. So any microprocessor should have a program counter in it. Microcontroller point of view will say it is a DPTR, data pointer, right? So then the next internal operation is, now the processor is doing a task, right? Then meanwhile some other priority task need to be done. Now you are playing a video game in your multiplexed. What do you mean by that? Multiplex means same pin you can use for address carry at sending address, and same lines or same pin you can use for carrying the data. So that means here if you see the pin diagram of 8085, here these lines can be used to send data and these lines can be used to carry the data. So same pin is used for multiple purpose, then that's why it is called multiplexed. So the pins here are multiplexed so that the number of pins, see 8085 has how many address lines? 16 address lines. How many data lines? 8 data lines. Total pins together how many? 16 plus 8. So you have 24 pins you need. Means 24 pins for this address and data. To reduce the lines, number of pins, the address and data lines are multiplexed. So that the meaning is this, right? The meaning is this. So here you have address and data buffer, right? So your memory you can connect it here. So any instruction it is fetched, it will be, see now you look at carefully at the microprocessor architecture of 8086. So you have address lines and data lines, and here you have buffer to store the data, right? So then once it is done, so this is called internal data bus. So it is data is bidirectional. Data is bidirectional. Address is sent from the microprocessor. So that's why it is drawn like this. So it is unidirectional. So how many 16 address lines it will send. So then that particular memory location is identified, and that data will be transferred onto the microprocessor using data bus. And once the data is on the microprocessor, will goes into the resistors. So processor will store the data temporarily using resistors. So 8086 has resistors like resistor B, resistor C, resistor D, resistor E. See, it is gate point of view, it is important. So D, E, H, L, they are called general purpose resistors. So you have here 6 general purpose resistors, each will store 8 bit of data, right? And temporarily you will store the data on the microprocessor using resistors. And so once the data is stored, then executing of the instruction is done by using ALU. So the symbol of ALU is like this, always right? The symbol of ALU is like this. So this one. In any architecture you find like this means it is ALU, arithmetic and logical unit. And in the side by side, you have an accumulator, one more resistor called accumulator A. Resistor A, B, C, D, E, H, and L. So these are the resistors store the data temporarily. So once the data is stored temporarily, then the processor will draw the instruction and your ALU will execute the instruction with the help of accumulators. And here you have temporary resistor. So it will perform the addition or subtraction. So it is 8-bit processor, means it has 8-bit ALU. So one temporary resistor you have. So once it is fetching, so with one 8-bit will be in accumulator, another 8-bit will be in temporary resistor. So these two 8 bits can be added at a time or subtracted at a time, right? So that's why this resistor, temporary resistor is used. So once the execution is done, you can know the status by using a resistor called flag resistor, or resistor means what? Flip-flops, set of resistors, right? So flag resistor is, right? So this is flag resistor, right? So then once the instruction is executed, then you need to fetch one more instruction, right? So see here, this instruction is of, this is an instruction register. It is decoded, and then what has to be done, the processor will do. So this is instruction decoder, right? It is instruction decoder. It will decode, and then it will tell the processor it has to do addition or subtraction kind of thing. Instruction is of two types. One is having two terms. One is opcode and operand. Opcode is decoded by using this instruction decoder, and on operand, you will perform the tasks, right? Right. Then the next instruction has to be fetched by the microprocessor. The next instruction is fetched by program counter, is what we have discussed now. So it is 16-bit program counter. So 64,000 locations it will point out. So how to define program counter? Program counter is a register which will point out the next memory location which has to be fetched by the microprocessor. Then you have, once the processor is doing certain tasks, then if any high priority task is coming, then you need a stop pointer. So what is stop pointer? Stop pointer will hold the address of the previously executed program. So that is what your program counter is. So now processor initiated instructions, operations, and then coming to the external operations is what I told you, like processor like will do read operation, write operation, like it is doing a memory operation or IO operation. So these are control lines. These read bar and write bar, they are called control lines. Why control? We'll see each and everything in detail. So read bar, write bar, so these are control lines. So address lines, right? Data lines, right? And then externally initiated operations you have hold acknowledge, ready, right? You have some, you need to connect your clock. So that clock connection done by using this X1 and X2 where you connect your crystal, and you have to give power supply. So plus 5 volts and ground. So these are called timing and control. Right, timing and control. Right. So then you have reset in and reset out. So to reset the processor. So all these things are done by using this. So the moment you press the reset, your program counter will become 0000. That means you can start a fresh your operation. So this is what the architecture, and these are all interrupts of 8085 microprocessors. So in the conclusion, now what the processor will do, what the functions performed by it, the capability of it depends upon its architecture. 80 8085 microprocessor architecture is. And the same thing you can see on the pin diagram. So you have address lines, you have address lines, you have data lines, you have control lines, right? You have control lines and externally initiated. So it is total 40 pin IC is what your 8085 microprocessor IC is. Now the same thing can be extended to 8085 microprocessors. 8086 microprocessors. So this is the architecture of the microprocessors. See, I explain from the basic what exactly the processor and all. So now I am sharing my this this thing, but whether you are understanding or not, then now let me see. Yeah. So are you with me? Up to now, what we have discussed? Yes. So today I introduce few words. What are they? Like address lines, data lines, control lines, resistors, ALU, program counter, stack pointer, right? And then this and all. So now the moment you see the architecture, you can identify, right? So then in sleep also you have to draw the architecture. We start from the sequence. Yes or no? Like your address lines and all. So now same thing can be seen now for 8085 microprocessor. So now let me show you the 8085 microprocessor architecture. So this is what important is, right? Little bit different, but don't worry what exactly it is. But you can see the same. I'll just this is very simplex form of your microprocessor architecture. Now to start with, right? I hope you are with me. Right. So now let us see. So here you can connect your memory. So when you are connecting your memory, you should have address bus, you should have data bus, right? So the processor will generate the address. So that's why this is unidirectional, right? This is address bus is unidirectional. See how the arrow mark is. So it will generate the address. So it is 8086 microprocessor. How many address lines it has? 20 address lines it has. So it will generate 20-bit address from where it has to fetch instruction. So the memory will connect here. So then once the memory is identified, the data is transferred by using data bus. So this data bus is used to transfer your data, and this data will goes into a queue. So this is called instruction queue. The difference between microprocessor, I mean 8085 and 8086, I will give you, don't worry, in the next class in detail. But what we have discussed, whether it is there with 8086 or not, now we are seeing. So these instructions will be passed to a queue, and each queue, that means each one can store 8-bit of data, right? So 8 bits, so like that you have 16 bits, like 16 bytes queue, and then here is your ALU. So this ALU draws the instruction from the queue, and this is what your instruction pointer or program counter, which we call, which will point out your memory location, right? So it is of 16 bit. So then it will draw the instruction, and this ALU will execute. See, this is what the symbol of ALU. Right? 16 data here, 16 data here, and it will perform the task. So it is an ALU, and nearby it will find out accumulator register. So general purpose registers here. So this is accumulator AX, base register BX, out resistor CS and DX. Then you have stack pointer, right? This is what your stack pointer. So what the terminology we have seen, now we can see on the architecture is, right? So this is your stack pointer, ALU, and flag resistor is. So like this, any microprocessor you see, the things which we discussed now, the basics which I gave you now, can be implemented or you can extend it, whether it is 8086, 8085, 80386, little bit different only, but this is same. You have address bus, data bus, instruction queue, ALU, resistors. Yes or no? So any architecture you can or you have to understand by this time now. So what we have discussed today, I'll summarize. Right? What what I have discussed up to now, I summarizes. Is it all right? Right? So we have just came up to the point of seeing the architecture of your 8086 microprocessor. Not started it, but a brief introduction is what I gave. Same thing you can extend it to 8086, 8085, 86 microcontroller also. The moment you see the architecture, the terms which we have discussed up to now can be seen. Is it all right? Okay, so in sleep also you have to draw the architecture of your 8085 thoroughly now, which is very important gate point of view. All right, okay. All right, so if you have any question, you can ask me. So today what we have discussed, like in the last class, we have given the summary of evolution of microprocessors. And in this class, we tried to see what is the architecture is, right? So in the architecture, some terminology related to microprocessor, or the moment we say the microprocessor, a microprocessor should have what? It should have, like, any microprocessor you say, the moment you say the microprocessor should have like address bus, data bus, control bus, ALU, resistors, program counter, flag register, like external things and all is what we have seen, and that's what we have seen in 8085 microprocessor. And I'll introduce 8086 architecture in the next class, which is very important in your JNU point of view. Right? If you have any doubts, you can ask me, like you can give me in the form of a message. Any questions you have up to now, you can message me. Right here in the left side, you have